Hello, my dear students. Myself S. Devi, Assistant Professor, Department of Artificial Intelligence and Data Science, Rogini College of Engineering and Technology. I am going to teach the subject Operating System and Cloud Basics. Today we are going to discuss about Docker architecture. Docker architecture is an open source platform for developing, shipping and running application inside lightweight portable container packages, application code, runtime libraries and dependencies together, ensuring the application runs consistency across different environments. For example, you have a Python program that needs Python 3.10 version and some libraries on your computer. You may have a different Python version which you have installed. Using Docker, you can put your Python program and the correct Python version in a container and it will run the same way on any computer without conflict. Docker follows a client server architecture. The client communicates with a background process, the Docker daemon, which does the heavy lifting of building, running and managing your container. Design, development, deployment, testing, releasing software Docker. This communication happens over a REST API, typically via Unix socket on Linux or an network interface for remote management. We will see about the core architecture model. We will see about Docker client. This is your command center. When you type command like Docker and a Docker build, you are using Docker client. So when you are typing your commands, then you are using Docker client. Next, Docker host. This is the machine where the magic happens. It runs the Docker daemon and provides the environment to execute and run containers. Docker registry. This is the remote repository for storing and distributing your Docker images. This interaction forms a simple yet powerful loop. You use the client to issue commands to the daemon on the host, which can pull images from a registry to run as container. In Docker, the meaning of push is uploading and pull means download. So this diagram illustrates the architecture of Docker model. As I told that push means uploading the Docker and pull means downloading the Docker. Execution, Docker run means it's executing, and when you type the command, you are using the command client section, and registry in the sense for storing and distributing your Docker images. There will be a remote repository, and we will see what is register, which you can pull the images from the register to run a container. The Docker component acts as the brain of your Docker installation. It runs on the Docker host. It listens for API in the sense application protocol interface request from the Docker client. It manages all Docker objects such as images, containers, networks, and volumes. It can communicate with other dominants to manage Docker services in multiple host environments like a Docker Swarm cluster. The Docker Swarm cluster is a group of Docker host machines that are joined together to work as a single virtual Docker engine. Second one is Docker client. That is, when you type your commands, you are using the Docker client. It translates the user command into Docker PS like a REST API request. These requests are sent to the Docker dominant for process. A single client can communicate with multiple dominants. Common command. Most commonly used command is for building an image from a Docker client. It is known as Docker build. Docker pull is pulling an image from the registry. Docker host. Docker host in the sense the virtual machine that provide the complete environment for executing and running container is known as Docker host. The host is a physical virtual machine that provide the complete environment for executing and running container. It consists of the operating system, the Docker domain, images that have been pulled or built, running container, network and storage components. First we will see what is image in Docker. A Docker image is a read-only template used to create container. It contains the instruction for creating a dominant container. It contains all the necessary code, libraries, configuration files and environment settings required for an application to run. The container contains the instruction for creating a Docker container. The contains the instruction for creating a Docker container. It acts as a blueprint or class in object-oriented programming for creating Docker container. It provides consistency and portability across different environment. Images are created using Docker files stored in registries like Docker Hub and can be easily pulled and pushed and shared. So container is runnable live instance of an image. If an image is a blueprint contained in the house built from the blueprint. It is a portable box for the software application. You can create, start, move, delete, stop, the container using the Docker API or CLI. Each container is isolated from other container and the host machine, having its own file system, networking and process space. You can run multiple containers from the same image. Containers are lightweighted because they share the host system kernel. Container can run on any system where Docker is installed, making them portable. This is the diagram. A developer who developed the Docker file, and it is then converted into Docker image, which the image is kept in the Docker container and stored in the Docker hub. If you are loading, then it is known as push the image. If we are downloading, it is known as pull the image. So resource limitation and process isolation in Docker. We will see what is namespace in Docker. Namespace or process isolation. Namespace are the features of Linux kernel that provide isolations of system resources. The Docker uses namespace to ensure each container has its own independent environment. Types of namespaces used for Docker. PID, process ID, isolates the process ID. So process inside a container have an independent set of process ID and cannot see the host process or other containers. NET namespace, it provides each container with its own network stack with own IP address, routing table and network interfaces. MNT namespace, MNT stands for mount, isolates file system mount points. Each container can have its own view of the file system. IPC, inter-process communication namespace, isolates inter-process communication resources like semaphore and message queues. The process in one namespace cannot access IPC resources of another namespace. IPC, inter-process communication. UTS, U stands for Unix, TS stands for time sharing namespace. Allow container to have their own host name and domain name. User namespace maps user ID inside the container to different user ID on different hosts. Registry, a registry is a scalable storage system for Docker image. Registry allow developer and organizing to store shared distributed image storage system for image, enabling sharing and distributing. Types of registries: public registry and private registry. The default public registry is Docker Hub, which contains a vast collection of community and official images. Docker Hub, for example, Docker Hub where anyone can publish or download images. Private registry, organization often use private registry like Harbor, AWS ECR or Google Artifact Registry, which is used to store proprietary images for security and control. It is used within organization to store images securely. Registries makes it easy to store, version and distribute images, make application deployment faster by allowing images to be pulled directly into the host system. We will see about the layer file system. The layer file system in Docker is a way of organizing the file of the Docker images into a multiple stack layer where each layer represents changes like adding, modifying or deleting files. Each layer is immutable, which cannot be changed once it is created. Layers are stacked on top of each other to form a final Docker image. Docker uses copy on write so that changes made in the container do not affect the underlying images layers. This system saves storage, speeds up build and allow multiple images to share the common layer efficiently. Thank you.